All right, so hi. We are Team the Moose. Our project is the 3D molecule visualization game, currently titled Molecular Mission. Our project is sponsored by Joe Lanzafame of RIT's chemistry department and coached by Jim Bellino. I'm Brian Hansen.
I'm Gabrielle Bennett.
I'm Jason Graves.
And I'm Maggie Hewitt.
And then our other two members should be here shortly, Brian Spates and Timothy Steen. So next we have a demo.
So we're going to start off with a demo of the current state of our project.
Yep. So with the demo, what we have here, this is our title screen. It's very similar to what we had before, but now we have a level select, and our level select is essentially our mothership. So we wanted kind of a sci-fi feel for the game, so we were able to have our artist create this kind of sci-fi-esque ship level. So here we have our first level. We have tutorial stars to basically tell you what goes on in the game. We've come a very long way since our last project. We actually have a fully modeled ship instead of, just being around in like a kind of open space. We have, a kind of a cave-like structure that kind of represents carbon sheets. So what you see on the screen, the HUD, your score, the controls, these stars basically are just telling you how to play the game and whatnot. So like right here we have a checkpoint, and here we have a spinning stick of death. If you touch it, you basically die. And if you collect any of the molecules, which are the objective of the game, as you'll see here, boom, your molecules go away and you're going to have to collect them again. So let's avoid the spinning stick of death and collect our molecules. We have the molecules gravitate towards you. The basic controls, W, A, S, D, A and D strafe, Q and E are move down and move up. Here we have a tractor beam, so what we envisioned would be like kind of big walls of molecules that would obstruct your progress, but you'd be able to basically, drag them away so that way you can keep going. And here we have won the game. Go.
All right, so the reason why we made this game is because we were charged with making something that would help students visualize simpler molecular structures. More specifically, taking that hieroglyph in the top right corner and translating it into a 3D structure you could see as you're flying through subspace. And we also decided to focus more on emphasizing static molecular structure versus chemical equations, because that's also what the sponsor wanted. One thing you might notice is that we have two new team members since we last presented. We have Tim and Gabby, who have joined us from the game design department. And we've also hired Damien, a 3D artist.
Okay, so Tim and I came onto the project to help these guys make their game a little more fun. So what they had in the beginning was kind of an open world, procedurally generated sort of game, and we decided to take it in an entirely new direction. So we decided on closed track levels and tighter controls, trying to get as much fun as we could out of it.
Yeah, we also created characters and a story. The game was meant to be simple, so the way we wanted to grow the fun was through the story and involving the character and other characters emotionally.
So what we ended up with was Max the Space Moose, and he's the sole survivor of his species, and he has to collect molecules in order to save himself from being stranded in space, basically. So we pitched that, the team ended up liking it.
And these are the changes we made. After proposing different ideas to the team, we went to the design doc and started nailing down the details. In terms of the story and the character, we came up with 3 different characters. Max the Moose, that's the main character. Gerald, which is the ship AI. He's not expressed much in the game right now. And the mothership. The mothership connects into the overworld. If you've played games like Mario, you know that you travel throughout the world in an overworld, which is played completely differently from the actual gameplay. But what it does is present different forms of gameplay and allow you to explore the world physically. We could just have a level select screen where you have different panels, but we wanted to immerse you in the world. We would have liked to have done more dialogue so that we could connect these characters emotionally, but time constraints and other limitations sort of held us back.
We added some mechanics like the cluster buster. You might have seen it in the demo, where you can fire a little phaser type thing to break apart molecules so you can collect them. That made things a lot more fun. The controls were tightened up a lot, especially by Tim. It's now a lot easier to use the controls, so use the mouse to steer and the WASD to kind of steer your ship. So it's kind of like standardized to what gamers would expect, but at the same time it's introduced very easily so that non-gamers can understand how to play it, because this is geared towards people who may not play games all the time.
Previously, the ship flew more like an actual airplane in terms of engaging thrusters and disengaging them. Now it's hold down the buttons. It just makes it a little bit more clear that when you press a button, there's an action associated with it, rather than press a button and it continues to act without your input. Going forward, we would like to add arrow controls to control the camera. In our playtest, some of the older players felt like you should control the game through the arrow keys, because originally games like Doom would control through the arrow keys. We think this is a good idea because mouse sensitivity changes depending on the platform you're on, but arrow keys don't change, so it's just a way of standardizing those controls. We also made changes to UI, but that's more your forte.
Yep, so we wanted to have the game be immersive as much as possible, so a lot of changes were made to UI to kind of make it feel more like a space shooter with the health bars at the bottom, and a lot of it wasn't implemented yet. There's going to be a molecular field guide that you can look through and see what kind of molecules you need to collect and what they do.
Many people ask us about the educational aspects of this game, but we face a challenge in making the game fun up front so that we could attract people to play the game, and we haven't had much time to work on the educational aspects. The molecular field guide aims to solve this problem by presenting information in a text format, which is not the way we would prefer to do it, but we're trying to teach people things, and if we can't find a way to do it through gameplay, then we'll do it through a text. And the level design is probably the thing that we have the most room to grow on. We've created the elements of the levels and the gameplay of the levels, but we haven't made any levels beyond the tutorial level you saw there. So what I can talk about right now without having anything to show you is that levels should be simple, and we should present the information as the player goes through them rather than up front. So you may have seen in the game that there's stars that have dialogue and they teach you how to play the game. We're going to present that throughout the level and slowly introduce the player to molecules and chemistry and gameplay. I think it's pretty important before we move forward to say that our artist had a lot to do with the level you saw there. We had a very basic structure, and he went and took it and made it into something really fun to play in. And I think that once we added that art, the levels just came to life in a way that none of us could have expected. So
They really did.
art is pretty key to level design. I'll talk about this slide just because I worked pretty closely with the artist, and in our dialogues, we were trying to find a way to have him give as much creative input as possible while not stepping on our toes in terms of the gameplay and the structure we wanted. What we came up with were 2 levels, the tutorial level and the mothership. The mothership plays a lot differently. It's mostly just visuals and a means to getting to the gameplay, but when you're inside the mothership, you start to feel as though you're actually Max and you're actually in his perilous situation. Lights flicker, and you can see the energy source in the center there. It's a vibrant environment. There's not a lot of complexity there, but it adds to the gameplay by building a world. So in the end, the gameplay is very simple. We made it accessible so that anybody who wanted to be a part of this world, a part of this educational experience, could play it. We made the molecules gravitate towards the player to make it simpler. We simplified the controls so that everything acted the way you wanted it to. And at its simplest form, the game is about collecting molecules and getting them back to the ship.
This is kind of the high concept of the game. You're playing as Max, you're a chemical engineer, you're trying to collect these molecules so that you can, repair your ship, and you're using the molecular field guide to guide you as you're playing through the levels.
And you can see pictured here the moose, Max himself. That's a 3D model. It's been textured. It hasn't been rigged and animated yet. There's many steps to the process to getting the character actually in the game and animating, and that is something we would do in the future. It's a shame that we haven't got it in at this point, but there's a lot of complexity to getting art and then integrating it into a game and tying it into gameplay.
So in addition to the main project deliverable of the game itself, there was also another requirement. The requirement of the professor wanted the ability to track students' progress through the game. So if he ever decided to make the game an assignment, people would go home, play the game. He could actually make sure that they did that. So in order to do that, we thought the easiest way to collect information from people distributedly playing the game was just to create a server with a persistence that can send the gameplay data to. And on top of that, we decided we also needed to be able to effectively authenticate students so that he can appropriately give people the grade that they deserve. So in order to accomplish that, we just created a very simple, mostly account management system. It's a one-page JS application with a Node.js backend with a MongoDB database, which is a little different for account administration than a lot of people use, but since we also have the dual purpose of wanting to use this as the storage for game state persistence between levels, the ability to stay at games, the ability to, you play the game, you come back, you want to be recognized again, start where you left off. So it was much easier with MongoDB to be able to just, with a schemaless database structure, to just shove whatever persistence data we wanted to in the database without having to really make any code changes. On top of that, it allows the professor to manage the students. It allows students to expire after a few years, and he can search and delete students if necessary. The current status is students can create accounts, they can normal account stuff, if you forget your password, you can get it back. The admin can search through the students by what course number they gave, what semester they were working in, and beyond that, it serves as the authentication wrapper around the game. So all the account logic is then divorced from the game itself. So if we want to deploy the game without all this user access functionality, it's much easier to because they're completely separate code bases.
Right, so game-wise, basically what you saw in the demo is pretty much what we have done. We have one complete level, art's finished and everything. We have the level select, the mothership is completely done and it looks great. We've got the players, we've got Max and the friendly ship AI, who is the person essentially talking to you in the tutorials. You can take damage, you can die. We have checkpoints in the game so that way when you do die and you make some sort of progress, you can at least save some of it. The core gameplay mechanics are all implemented, and essentially the tutorials are good to go to teach the player how to play the game, so that way they're not just thrown in and not knowing what to do.
All right, so in terms of the future, there's a lot of stuff that still needs to happen to make this game playable. In general, our focus for this iteration was to make a framework that's fun, that a future team can extend and add more chemistry to. So the main focus for future iterations will be adding that additional chemistry education. So this would mean additional molecular geometries, molecular interaction physics. So when you see two molecules collide within the game, you'll actually be able to see the molecular forces effects on that collision. In terms of a continued playability focus, apart from simply needing more levels than the first level we created, we also expect them to implement a purchasable system where they can buy ship upgrades such as more speed or more health, or other things such as new mechanics like the tractor beam. You could purchase something else along those lines. And finally, the last thing we expect that they will need to implement is an end-of-game scenario where they'll conclude the plot that we sort of outlined thus far.
All right, so the first semester challenges were basically we had 4 software engineers attempting game design. I know that in software engineering, most of the projects follow a certain script of, gather requirements, come up with a design, make the design and test. But nowhere in our curriculum do we really have come up with a story and characters, which was very challenging for us. That's why we're so grateful we got to work with 2 game design students and then an artist. Also, we're not very artistic, we discovered. And then in the second semester, we were presented with a fantastic design, but it was totally new and foreign to us and different from what we had been doing. And going back and redoing all of our existing code was quite challenging. During week 11 of spring semester, Chrome just decided to drop Unity plugin support, so we had to upgrade from Unity 4.6 to Unity 5, which wasn't as simple as just opening the project in Unity 5. It required some actually converting C# scripts. Understanding the graphical limitations of the browser, since we're not 3D artists and we don't have tons of experience and knowledge with the limitations of the browser, understanding what we could and couldn't do was kind of trial and error for a while. And version control in Git is very challenging with a lot of the files that we used because we had so much art in our game, and basically every time a level got updated, we always were dealing with merge conflicts in generated code, which was a challenge.
So really quick, here's some things that went well. New technical skills, a lot of us, this is our first project here working with Unity, and some of us were able to make some really cool side projects with it. I know Maggie had that really cool Fox demo. And our new team members, Tim and Gabby and Damien were all fantastic, and they had great ideas. They were able to come up with, help us with our game design. And 1 week sprints helped us out by, giving us some more strive to get things done right away. And, again, no one dropped out.
Questions?
So you mentioned the challenge with the Git repository and dealing with the blobs and that. So how did you go about handling that? What's the separation of concerns there between aspects of application?
So Unity allows you to describe the blob assets as text, which we did for a while in the first semester, but it ended up being worse than actually having to deal with the blob assets because it creates these never-ending merge conflicts, whereas before it's ignored. So we were also using pull requests inside of GitHub so that we could review each other's code before it went into master. So having thousands upon thousands of lines of nonsensical configuration files made the code review process nearly impossible. So we decided to go back to just using the blobs. And then what we did is we made sure only scene changes, which are the things that change those blobs, only happen in master. And so your pull request has a list of scene changes that have to happen, and you only commit code changes in the pull request, and then all scene changes are done in master where there won't be any merge conflicts.
So, could you describe a little bit more about how you put together kind of the architecture or the backbone for your Unity application? Like, was there a set of modules that you divided your different files into? Maybe there's like a standard for game development, but how did you kind of organize your code and your assets in that project?
I guess I'll answer this. We tried to follow a model view controller style and separate it into behaviors, controls, and then the others, but it ended up mainly being behaviors and model, which is behaviors can be controls or basically behaviors are model and control. And Unity promotes that structure. I don't know if it's really preferable, but it's the way we fell into. That's sort of what Unity does. And
Yeah, a lot of it is informed by the Unity existing structure, where everything that you put inside of the scene is a game object, and then you apply behaviors to those game objects.
Additionally, we added an event system. Unity has a send message system, but it doesn't have a dedicated event system that we were comfortable with. I wouldn't say we are too happy with our event system. You start chasing things around, it starts to become spaghetti code. But it did what we needed it to.
Two questions. The first is, I think you mentioned that you need to upgrade to 5.0, including Chrome, or they do stop supporting 4.7.
No, they stopped supporting the web any plugins. So if you haven't noticed, a lot of your plugins don't work in Chrome anymore since about 3 weeks ago.
Okay.
Specific types of plugins that use some sort of native compilation thing that's insecure. So we had to upgrade to 5 because 5 supported compilation to JavaScript from C# using emscript in ASM.js. So that's the target we're going for now, which is a completely different thing. So it wasn't just upgrading, so like deprecated libraries, we also had to change the build structure and get rid of any functionality that wasn't supported by the build target.
So the next time you upgrade, are you pretty much sub 2? Or?
Well, it depends if people keep supporting ASM.js, if that gains support, if it loses support. I mean, browser world's pretty fickle.
The second question, why is Space Moose?
Yeah, that's the name of our team.
Answer, why not?
I was going to say, that where you're supposed to be, why not a Space Moose? Well, like,
We started as Brian really wanted a team name with an animal in it, and I think.
oh, so that's natural Space Moose.
Yeah.
Yeah, like that's why our name is the Moose, and when Gabby and Tim joined us, they kind of springboarded off of our team name and invented Max the Space Moose.
One more question. You said there's a few things that you would like to do in the future. This is the final presentation. What is
Future teams. So the idea is to have this continue on next semester, next year with a new team. And so we're just trying to lay the foundation so that they can move forward without too much ramp up.
Let's thank the team.
We did.
You said you were rigatoni.
We are.
We are.
That's our, Linguini is the project. Rigatoni is the team.
It's like Beats by Dre, only better.
Way better.
All right, we are Team Rigatoni, and our product is Linguini. So let's get started. We are here, our sponsor is Cecilia Alm. She's a professor in the College of Liberal Arts. So just to start, let's have a little bit of background about what we're trying to solve by working on Linguini here. So the field that we're working with is computational linguistics, also known as natural language processing. It's an area that looks to use computers and programming techniques to analyze text and gain insights from them. That can be things like spam detection, where you're trying to find out which emails are selling you Viagra. It can be things like sentiment analysis, where you find out if a review was a positive or a negative review. And there's also more practical kind of applications like named entity recognition, where you're looking at a sentence and you want to find out which words in this sentence refer to an actual named person or place as opposed to just being a verb. So these are the sort of things that researchers are currently working on and having different levels of success with in trying to use computers to answer these questions, and it's a very interesting field that people are working in right now. So for our project, we were looking to develop something to help out language students who are taking classes in linguistics, want to know how computers can be used to enhance linguistic analysis, but maybe don't quite have the same experience as, say, a computer science or a software engineering student. When people are working with computational linguistics, there are some barriers that you kind of have to get around in order to do your analysis. You need some programming experience because a lot of this stuff is going to require you to write code in order to do any analysis. You have the barrier of building a pipeline where you're going to have to acquire some text, somehow parse it or load it into your memory, and then run analysis on it and store your results somehow and maybe visualize the results. You have to build each step of the process, and that takes time. There's also a large array of libraries that are out there for doing different text analysis, and it's kind of hard to curate them and know which one is best for different applications, and some of them have different levels of bugginess or different dependency requirements, so it's kind of hard to figure out what exactly do you need for your project. So for Linguini, what we wanted to do was build an application that allows students to log into it, upload their own documents, and analyze them, and to do that without any programming knowledge, but have some sort of meaningful results come out as a result of that. We also wanted to make sure that our project did adequate unit testing so that it was easy to see what the intentions were when the code was written and make sure that everything's working properly. We wanted to do user testing, get feedback from actual students on the UI or the functionality of the project to make sure that it's something that they'd want to use in a classroom. And we wanted to make sure that we included documentation both for developers and for users of the product. So let's kind of walk you through a little bit with some screenshots about what Linguini is, and then a little later we'll also do a demo. So there are two main features that this product provides. The first one is called corpora management, corpora being a fancy plural word meaning documents. So it's the text that you could upload and analyze. Our system provides a set of corpora for any user who logs in for the first time. They get poems or excerpts from books or plays so that they have documents already available that they can work with. We allow you to upload your own documents and do your own analysis on those. We also let you tag the documents with different informative tags and then search through those. So if somebody had a large library of a lot of documents, they could search for Shakespeare and then they would know where are the Shakespeare documents. It'll show them. So here's a screenshot of some of the corpora that we provide for any user who logs in for the first time. You can see we have a couple news articles, we have a couple Shakespeare plays, we have Tom Sawyer, so they come in already with tags associated with them so that people can see what each one kind of is used for. And the idea is we give you a variety of texts of different styles and different ages so that you could analyze the language and compare and contrast them. The other main set of features that our product delivers is text analysis. We run our own code. We kind of act as the middleman where we call the functions provided by several different libraries and we just throw in the contents of the documents into those functions so that the user never has to interact with any code. And that allows us to basically add each operation as its own little module, and we can do things like part of speech tagging, where you take a sentence, find out the parts of speech of each word in it. We allow you to do topic modeling, where you group the words that are in a document or a set of documents by finding the words that have similar topics. We can do word cloud generation, we can clean your text, so all of this is stuff that ordinarily you would have to write a function or a class to go through your code and do that programmatically. We just make it so that you just click a button to do it. So here's a screenshot of the analysis workflow, which we'll go over in the demo, but it basically is a step-by-step process for selecting your documents, choosing how you want to clean it, and then choosing how you want to analyze it. You click a button, and then it gives you the outcome.
So our architecture hasn't changed much since our interim presentation. But starting at the bottom, we have a MongoDB database in our domain layer. We are running 2 web servers, one in Node.js and Express, one in Python and Tornado, which both access the MongoDB database directly. The Python web server is responsible for doing most of the analysis because we use a lot of NLTK and that's in Python. The Node.js web server serves up the web application that is displayed to the user, which is in HTML, CSS, Angular, and that's how that works. We have a transaction model so that when a user tries to do an analysis on the client, this sort of JSON object is what is sent to the Python server. It specifies like what type of operation to be done, what library to use, which user requested it, and all the things to be performed, and the response is sent back to the analysis ID I'll look up later. Yeah, since you can see there, we allow you to specify a library to use for transactions, which means we're not really limited to Python and Tornado. Like, we don't have to just do NLTK. We can, if we wanted to do core NLP, just spin up a Java web server that understands these transactions or any other language, and we can extend it in any way we want to. For technology, I've mentioned most of these already. Angular for the front end, Express, NLTK, Node, Python in the application layer, MongoDB on the back end. For most of our developer tools, we use Sublime Text, GitHub, Travis for continuous integration, and Waffle.io for project management.
All right, so let's walk through a quick demo of the product so you can kind of see how it works. So this is Linguini. It's a web server that you can just go to if you navigate to linguini.rit.edu, and it's designed so that any student could log in from home or from the RIT campus and access the website. You log in just by putting in your RIT account, which we authorize using LDAP. So let me just log in real quick here, and you can see now I'm logged in. So from the home page, what we show off here is just a basic splash screen that gives you a rundown of the types of features that we would be giving a user to work with. So you can see it allows you to visualize your natural language data. It's designed so that we could, instead of just getting text results, you can also get kind of something that you can look at and interpret a little easier than just staring at a bunch of numbers. And like we were showing with the screenshots there, it gives you that option of having your corpora, and you can manage them however it works for you. So let's take a look at the corpora section here. You can see we have a bunch of pre-provided text files that were already uploaded when I first created my account. And if I wanted to look inside one of them, I can see here's Macbeth, and it just goes down the lines of the text like that. It uploads raw text as it is when you have it, so if there's line breaks, if there's paragraph marks or other weird symbols, it's going to upload them completely as is. And if you want to get rid of them, then that's what you can do when you're cleaning the text as part of an analysis. So you can see that we have different tags here, like Macbeth has Shakespeare, apparently it's about death. And if I wanted to, I could just search for one of these, and if I start Shakespeare, then you can see that those come up and they filter as you go. Creating a corpus is very simple. All it is you choose the file that you want to upload. If I wanted to say, grab Macbeth again, and I wanted to call this Macbeth Part 2, then you just create the corpus, and it's right down there. And if I wanted to tag this as Shakespeare, it's a very simple process to just click add, and there it is. So that's corpora management. It's designed to be very simple, straightforward, and quick for people to go through and start working with their text. The next step is the analysis section. So as you can see here, there's a couple that I already used from Friday when we were showing off the poster presentation, and we did some demos then. But the way this works is it allows you to create your own analysis just from scratch, so we'll head into that. So what we're going to do here is the first step is you select your corpora, and it gives you a list of all the ones that you've already uploaded. So we'll grab this news article about the earthquakes from a couple weeks ago, or from a week ago. If you wanted, you could do different cleanup processes. So that can be things like removing capitalization if you want to use all lowercase. It could also be removing punctuation. Also stemming, which is where you take your words and you remove any of the endings to kind of get the word root. So walk, walking, walked, those all get interpreted as walk, for example. So that's another way to kind of standardize the text that you're working with. So you could use those if you wanted to, and you can choose more than one just by clicking on more than one. Next we have tokenization. A lot of analysis operations want the text to be split into individual word tokens in order to work with them. For example, part-of-speech tagging, if it were to operate, it would need to have each individual word as its own token so that I could say what part of speech is this word, what part of speech is that word. So we'll just pick a real simple one where we'll just tokenize by splitting it on the spaces that appear. And then the last step is you just choose which analysis that you want to run. So I was saying part-of-speech tagging. We'll just do part-of-speech tagging real quick here. And once you select, you can't select more than one analysis. The way the transaction is designed is you can have 0 to many cleanups. You can have 1 to many tokenizations, but you can only have one analysis. So when you're finished, you just create your analysis, and then it pops up right here. And if I click on that, what it's going to show as a default view is just the raw JSON data that gets returned from the system. This is designed so that if somebody wanted to do additional analysis on their own, if they wanted to maybe write a program to interpret these results, or just kind of dump it into a text editor and look at it, that's available to them. So we wanted to make sure that the raw information is there. The other view that we have, though, is a visualization, which is custom for each different operation that runs, but it's designed so that you can kind of get a easier to interpret view of the data that's being generated here. So what we have here in this part of speech tag analysis is the contents of the article, and as you mouse over them, you will see different parts of speech tags that get popped up in a little bubble there. So we could see the word more gets tagged with this JJR, which tells us that it's a type of adjective. If we had kills, it gets tagged as a VBZ, which is a type of verb. So obviously, if you're not studying language science, you're not going to know what these part-of-speech tags actually are, but the idea is that this is used as kind of a lab or like a lesson that you would be taking the class, and then you look at this, and then you look it up on your own time as part of the homework assignment, and then you learn, okay, VBZ stands for verb, and now you can interpret it better. So we allow you to just kind of walk through the sentence by highlighting those different things. So that's the system as it is, and you can see that as you add your new analyses, they just keep getting added, and if you wanted to delete it, it's just as simple as clicking the trash can and it's gone. These things will persist after you log out, so it's all there for you. So let's go back into the presentation now.
All right, so testing is something that was very important for us. We wanted to have a really good testing plan. So we had a few different approaches we used, the primary one being unit testing, and we also used Travis CI and had automated unit testing through that. In addition to that, we conducted user testing with some language science classes here on campus. That's something that we did for the first time at the end of the fall semester, and we recently did again at the end of spring semester with some of the new features we implemented then. So we had unit testing on both the Node side and the Python side using separate frameworks. What we ended up finding was that for Python, the unit testing wasn't as useful for us, primarily because many of our unit tests didn't end up traversing all of the code from our Python server receiving the request to it sending the response back. So we ended up running the unit tests, having them run successfully, everything looked great, and then later we would find out there were actually still issues with the code. So what we ended up doing was using Postman to do our Python testing, which is a Chrome plugin that allows you to basically send a REST request to your server and see what reply it sends back. So we were able to kind of construct some responses and see what kind of results we were actually getting, and that way it would cover the entire code base of the Python server from start to finish instead of just different pieces of it. Unfortunately, we did run into some issues using Travis for our project. The primary issues with Travis were installing dependencies for our Python server. Because a lot of the NLTK libraries have so many dependencies, it takes Travis a long time to try to install all of those and get them working. In particular, there was a library called GenSim that we were using for topic modeling that can take upwards of 20 or 30 minutes to install with all of its various dependencies, and Travis just wasn't able to keep up with that. So because of that, we ended up abandoning it, and we weren't able to use it for our testing, unfortunately. User testing we performed, like I said, in the fall and the spring, and it was useful for us because we got to see how the system would perform when we had a full classroom of people all trying to run analyses at the same time. And it also gave us a lot of feedback on the user interface, suggestions for improvement, and bugs. So here's some of the user feedback we got. A lot of people thought that creating analysis wasn't showing up in a fast enough manner, so they would click create analysis and the system just wasn't responding quickly enough. So that was one of the major pieces of feedback we got. We did get a lot of feedback about the UI. In general, people seemed to like it, but we also had a lot of, just little things that people thought we could do to make the system more clear on how to use.
So some project risks moving forward. Right now, we're currently hosting our application on the ITS cloud stack. We are continuing to do so in the future. But because we delivered a web application, there's going to be some necessary maintenance down the road. What if there's vulnerabilities discovered in the web application server? There's going to be that necessary maintenance in order to keep the server secure over time. In terms of project scalability, we do have some bottlenecks if we have a classroom full of 25 or 30 students performing analytics on large data sets. It takes some time for those results to return to the user. Lastly, there are challenges in creating these visualizations. We're using the d3.js framework to create visualizations, and you really have to understand JavaScript and HTML very well to create these visualizations, and that learner's curve of bringing on a new team member and teaching D3 could be a risk. Performance issues. So as I mentioned, some of the analyses are computationally intensive, and consequently in our UI, because we failed to provide that feedback on these in-progress analyses, users are left wondering what happened to their analyses. Is the system even processing it? So that would definitely be something that could be worked on in the future to improve the product. In terms of more future work, again, we need to make those performance enhancements in order to remove those bottlenecks from the system. We'd like to integrate with Stanford Core NLP. This would allow us to provide more analytics operations to end users. We'd like to increase the number of visualizations in our system. And we'd also like to integrate with Twitter. That way users could analyze tweets, just to allow a more fun way to interact and have more interesting analytics you can perform. So are there any questions?
Back there.
So what sort of security concerns did you design for? I noticed that you have to send username and password to the server, but you don't
go and then put input output and match, which makes sense because that's not what unit testing is. But I guess I'm wondering why you didn't go ahead and do great like automated functional tests or higher level integration tests or something that would go and then test the inputs and match the output.
Yeah, I think what we really found was that using the Postman Chrome plugin was so much easier because it enabled us to really quickly build a set of tests and then we could just kind of run them all at once. So it kind of provided that automated testing for us in a way that was a lot easier and lower maintenance to set up.
But you have to run those manually, right?
So we started doing the integration testing towards the end as we had the full transaction back and forth going between Node and Python. And so at that point, we didn't have the time to develop that Postman system, but Postman does offer a command line interface that would allow you to automate a set of requests that you could then test and verify. So that's something that's doable, but we just didn't implement it in the time that we had for our product.
Okay.
Do you really think that the users are more interested in that raw output view every time as the default view? Because to me, I would imagine they would go right to the visualization and then into like the analysis. So I was just curious if there's like user research that went behind that choice or not.
I think the main reason for it is that not all of the analyses actually have visualizations at the moment. So for the ones that we haven't managed to implement one for, we still want some method of viewing the results.
Yeah, that makes sense.
Yeah.
Did you come up with a plan for addressing the issue of bottlenecking when you had an entire class working on your site?
So a lot of it comes down to right now is that we are running 2 web servers and the Python one is really, really basic. It's basically just the issue. It's single-threaded almost, and the issue is we need to choose a better web server. So that's how we would address it.
Yeah, we looked into it. Python is very easy to do multi-threaded processing, so that would be the first step, would be to add on additional threads. You could also add additional servers and use that extra processing power, and then just use a task scheduler to kind of select which server is going to be doing the processing for each request. We also looked at potentially doing caching, so that if you have 30 students all doing the same assignment and the first step is do part-of-speech tagging on Macbeth, then it doesn't make sense to run it 30 times if everyone's generating the exact same output. So that's something we didn't get to, but we'd like to possibly cache results so that identical ones give you the same output.
Is there a reason you didn't include the standard default set of for
Mainly because of, like we mentioned earlier with Travis and the integration issues with the dependencies there. One thing that we didn't mention was we were using Python 3, and Python 3 and Python 2 are not very happy friends, and NLTK in particular has had some issues with the transition to Python 3.
All right, so we are Team P5T. We worked on the presentation, proposal, and paper program permissions tool. I'm James Fitzgerald.
I'm Richard Lachlan.
I'm Alex Kelly. Jacob Siegel.
Our sponsor was Nathan Clays.
So just a quick agenda. We're going to go over the background for this project, the overall system design, then we've got a demo, some future work, and then some reflections. So this is our sponsor. It is the Center of Excellence for Suicide Prevention. It is one of the centers of excellence in the U.S. Department of Veterans Affairs. And basically what they do there is they do a lot of research in the field of suicide prevention, a lot of research programs and studies and things like that. So they wanted to replace this manual email-based system with a web system. So basically what they were doing to manage their projects was just going through these really long email chains where they would say, you know, did you do this? Did this get done? Did this grant get approved? Stuff like that. So it was a really complicated and unintuitive way to do it. So what they wanted was a single point of access where everybody could log in and just look and find the status of these things, update the status themselves, and then upload all their related artifacts and documents. So it would basically, ideally, have all these things grouped together under a single program so they could just go ahead and look at it. And then there's also the ability to associate information inside the system with the information outside. So basically this was going to be a web crawler where it would go to journal websites, scientific websites, and find places where their work had been cited. The asterisk is there because it can't happen while people are using the system. So that information just has to be added offline, basically. And this is a visual representation of what a program actually is. So a program can contain things like a media interview, research articles, a conference presentation, grants, journal articles, and then other, which is just anything that doesn't fit into one of those categories that they feel is related and should be uploaded. And all of those can have things like URLs added to them and descriptions and things like that.
All right, so we had some design requirements that were put upon us before the start of the project. And it basically forced us to use the Windows stack of things. So we had to use Windows Server, we had to deal with Internet Explorer 8, which was probably the most restrictive requirement. But you know, in general, we're using Microsoft-based products. So the idea is that, you know, for the server side of things, it kind of looks similar to this, where you have the user, they're interacting with the server, the P5P website, and then for the databases, you have both the website's database and the database for the crawler. So you'll see this diagram later, but with the other parts sort of interacting here. So if you're familiar at all with ASP.NET, it kind of looks like this from the super duper high level. You've got the user sending in request, and it's going through an authentication filter, and then it hits a bunch of controllers which interact with the database. And so the high-level design of this is that, you know, eventually just falls straight through and then comes back out to the user. So for our models, we were looking at something along the lines of this. So we've got artifacts which have multiple different types. You've got your research article, journal article, conference presentation, etc. And then, you know, you've got your researchers, which can be authors on each of those articles, but they're not the only people that can be authors on an actual artifact. So you have to have the capability to support authors from outside the system, which was a bit of a pain throughout implementation. Yep, so this is.
So then, as opposed to the kind of system design built for the site, this would be the system design for the crawler. The idea here was to have the crawler either run manually every, I don't know, so often, couple weeks, or whenever they added perhaps a certain number of new articles to their database that they needed the external metadata for. So as you can see from this diagram, it doesn't interact with any of the website. It doesn't touch the website database. It just interacts with its own database on its own time.
And that was done primarily because the quality of the information coming from the crawler is not going to be as high as information entered directly by the user. The information that the crawler scrapes from various websites might be complete garbage, and so we didn't want that information ending up in the website database and getting in the way of stuff that users had actually manually entered.
Right. And then this is an expanded system design of just the crawler itself. The idea to have kind of a generic crawler that can work for every site is sort of not possible. So we took a modular approach instead. We have this main kernel that generally runs everything. It has a thread pool and a logger, so it can manage the various parts of the crawler system. When it's initialized by user-defined configurations. Currently, we have an XML reader module for that and some XML configuration files. And it connects to our Microsoft SQL database if they decided to add another database of another type, maybe a NoSQL database. Down the line, they could set up a module for that as well. And then since websites, they're all different, there's not going to be a standard layout for like a scholarly resource site. The data mining is also broken up into modules. Currently, we decided to work with SiteCRX. It's Pennsylvania State's own kind of open scholarly resource. And the reason we decided upon that initially is We were looking through sites. Most of the scholarly resources, obviously, they're not free. And the ones that are, they don't really have any API support for accessing their data programmatically. Google Scholar definitely doesn't, and they don't really have any plans to in the future. So we found this, and we saw, hey, they're working with something called the Open Archive Initiative, or OAI, which is a API that has been designed so that a scholarly database can be accessed programmatically and can provide all the information that you might want that is displayed on their site. So we took on the site, started working with it, and then as we were implementing the crawler for it, or the crawler module, we discovered, oh, wait a minute, they've actually disabled the information that we need in their API. So there was no way to get citation data from that. But luckily, aside from, they had, in their HTML, they had a very easy way to access citations for articles. And thankfully, they had, for citation pages, an XML RSS feed format that we can easily run through. It's great.
All right, so we're going to do the demo. Actually, shrink that down. So this is the front page of the website. This is what you're greeted with when you first arrive. And a new user would go up and register. Go to the registration page, and they can, they have to type in the username, the password, all that fun stuff. They have to provide their personal information so that researchers within the system can know, who they're working with. It's not just some generic username. It's actually a Bob Smith versus, B Smith or something like that. And they also have to provide a primary affiliation, which is essentially what group that researcher is from. So the initial goal was for a very small group of researchers to use this tool, but they eventually hoped to expand it out to a much larger group, and so they wanted the capability to be able to specify, what your title is, what group you came from, what your email is, because you might not know the person very well, just from their name alone. So I'll type in a quick. And so it does validation on the page. So if you forgot to type something in, it will let you know. We chose not to use popovers here, which would have been nicer. It would have been a much cleaner user experience because they don't perform very well with Internet Explorer 8. And after looking for a solution for quite a while, we eventually decided that although this solution is less beautiful, it works and it provides the information that they need without breaking the interface. So this is the actual login page, like when you've actually arrived in the actual system. This is what you're greeted with. It's a simple search box. We wanted to keep this page very simple so that researchers could come in and look for the different people within the system. Right now there's two that match this particular query. And then we're going to go in, but the main meat of the application is in programs. So a particular program might be like this. This is a simple test program. It might be to gauge the effects of suicide or to gauge the effects of alcohol on the prevalence of suicide. And that information would be at the name of the program. And then researchers can simply add in research articles and journal articles and different things like that. So they can come in here and say, a cool picture, whatever they need to upload or cite, they can actually do. So here's an example of that. So upload a file. Got some images set aside for this purpose. And then they can easily download that simple file and view it, that sort of thing. And so they can go through here and they can add all the different things that they need to basically store this information in a form that is easily accessible by the entire group of researchers. It's not in a single email chain. It's not spread out across a bunch of different computers. It's in a single source where they can access it. So let's see. So let's add a more interesting. So like the research article, the journal article, and the others are all of the same sort of type. They only have a description, but some of these are a little more, more intense, like the conference presentation. So it has to tell they have to write down, where the conference is, what it's going to be, what it's about, what time it starts, that sort of thing. So they could write down. And it might be. And so all the forms, do validation and whatnot. So it's conference name might be. Maybe it's next week, a couple hours from now. And if I go down to conference presentations, it shows up here. So they can add and remove different authors. They can add an author that's not currently in the system. Peterson shows up there. There's a lot of little usability features that have been placed in here with the sole intent of helping them get their work done and providing that information in an easily accessible form. One of the features that they wanted the most was the ability to download all of the artifacts that have been put into a particular program in one go, so that if they get audited or if they just want to preserve those files in a format that they have on their person, they can do so easily. With email, they'd have to dig through multiple emails and pull out each of those different pieces and manage it that way. So we provide a download program artifact package, which lets them download just a zip file of all the different pieces. And so here's research articles, and it's got all the images and things, and I actually have to extract that to read it. But here's the URL that I added to that conference presentation, the metadata that's associated with that particular presentation. And this is just a tool that provides them with all of these files in a format that they can then easily use instead of having to dig through emails. That's sort of the takeaway. Okay. So, and so the idea is that Johnny Appleseed is associated with that program, and so he can come in here and someone else can look at Johnny Appleseed and say, oh look, they're associated with this program and find the program. So there's links throughout to kind of connect all the different pieces together. On top of this, there's a notification system. There is the ability to, not in this demo, but there's the ability to set up reminders on grants. So one of the things about grants is that you have to provide updates as you go along through your research, and so there's the ability to specify reminders about when those particular things are coming up. All right, so we're going to go back to the, not the speaker notes, I want to go back to the, it's up here. Okay.
All right, so just to go over some future work that's going to be done by us. We still have some final testing to do on a couple of different pieces, as well as some bug fixes. One of the big things that we still have to do is we have to comment our code, because currently I think our comment density is like 2% or something really, really negligible. Yep. So in order to improve readability, we're going to do that. We also have to create a comprehensive user manual to describe how to use the website for the basic user, as well as how to create the different web crawler modules for future teams or future developers that are going to be using the system. We also have to integrate a couple different pieces of functionality, mainly being IRB status, just setting and displaying it, as well as more robust notifications with more links, again, to help navigate, help the user navigate through the system easier. We also have to format our code a little bit more consistently, again, to improve readability for future users and developers. And future work, future work by others, others being future developers, maybe a future team that is brought on board to further the progress of this project. The main thing being crawler work, which is creation of additional modules that point to specific websites to help scrape that metadata, and as well as attaching the crawler framework to the current website, because currently it can extract data from websites and store it in a database, but that database is not currently accessed by the website system itself. So a couple different ways they could do this is implementing it through maybe the search functionality, or maybe just add it straight to the other database if they really wanted to. But those are just a couple examples of future crawler work that future teams could do.
So, as far as reflections go, the crawler, we appropriately assessed that as the largest risk from the get-go. We were, well, as far as that goes, finding sources proved difficult, obviously. And there's somewhat of a legality issue with web scraping and copyright as far as scholarly databases go. At most, we could probably get authors' abstract information without running into legal trouble. And as far as a comparison between the first half and the second half, our documentation and our metrics were much better this semester than they were in the first.
To point out some things that didn't go so well, we tried to get a head start on planning when multiple releases would be due. However, because we did this before we started implementing, we sometimes did not give ourselves enough time, which resulted in artificial deadlines leading to schedule slide. So, for example, we had a code freeze that was scheduled for a couple weeks ago, but we had to push it 1 week. And then also, we could have done more comprehensive testing. The main form of testing we did was user testing from future users of the system itself. So whenever we would create a new release or publish, we would send it to the client, and they themselves would test it, and they would also get some of their employees to test it as well. And we just made changes based off the feedback.
Anyone have any questions? Sure we do.
I have a product question.
Sure.
Actually, two questions.
Sure.
First of all, how does it handle file changes? Is there a version system on how to...
Yes. So let me actually just run over to the actual demo real quick. It's actually in the same. There we go. So if you upload a file, so let's here, we got one right here, right? If you upload a second one, you can update the file that's there, and it will preserve both versions of the file, and it will change the one that's displayed in front to the second version, and you can also get the revisions, and it just keeps a simple numbered revision of this one was first, and on and on.
My second question was about things that aren't necessarily files, like decisions that were made about something.
Sure.
How do you record those snippets of it?
Right. Those things would have to be recorded in a text file of some form and uploaded as a file. We don't have a mechanism right now to make a comment. There is a feature that we wanted to implement and will probably have done before the actual delivery that will allow them to change the status of a program through, it's just opened all the way to it's completed, and in there they'd be able to either upload a file or make a comment as to the status and why that status changed.
The reason I asked, you mentioned that it was kind of a replacement for
Right.
there's things in email that just file.
Right.
Okay.
Makes sense.
Was MVC3 a customer requirement as well?
Yes. Yeah, they were very specific in terms of the actual architecture that we had to use, because they plan to deploy this in an environment that already exists, and they wanted to make sure it was compatible. They didn't want to have to set up a whole new setup just for this program.
Did you lose out on anything because you had to still support IE8?
If we did, it was mostly user interface features like the popovers. There were other things that we erred on the side of caution in terms of IE8 where we weren't exactly sure if they would break in IE. We just chose to do it in a way that we knew would not break. So I would say, yeah, and the interface probably lost out in a bunch of ways as a result of having to support IE8. If we could go to 9 or 10 or 11, it would have been probably much prettier. But we do use Bootstrap to handle some of the compatibility issues, or at least as many as Bootstrap can handle. And you can probably tell it's Bootstrap just by looking at it. It looks like a Bootstrap UI.
Is sponsor want any kind of access control? Because in an email chain, there's a limited set of people who are
Right.
looking at things.
Yeah, we asked him a few times what, in terms of like security and permissions, he cared about. He seemed to sort of dismiss the idea. He said it would, it'd be on their central, their internal network, and that only the people that would work there would actually have access to it. With that in mind, though, we did implement a log that keeps track of changes that take place to all the different pieces, and then nothing is actually ever deleted. It's only ever marked as archived. And then they can go through and clean it up from the database. So if someone did decide to, delete everything and then storm out and quit, they wouldn't be very successful unless they were already in charge of the database, which would be bigger problems if they are.
Any other questions?
You mentioned affiliation. Didn't see that in the form.
Yeah. Yeah, so the affiliations, they're able to set their primary affiliation, but as for setting a secondary or third or fourth email affiliation, we haven't set that up yet. The feature is mostly complete.
Like, how did you actually set that?
It was in the registration. So if I log out real quick, it's at the bottom of the registration form. I typed it in pretty quick because watching me do data entry for a demo is pretty boring. It's the organization that they're affiliated with, what their title is. Right. Yeah, no, it's just who they are and a brief sort of description as to what they do.